Today's lesson is going to be all about solutions and properties of solutions. Okay, so we've already talked about solutions before. You guys will recognize the pyramid of matter. Solutions lie actually right here. They are homogeneous mixtures. Okay, so they are not a chemical combination, they are a physical blend. So, two or more substances that happen to be kind of in the same place, they can have different things in them, they can have different proportions, different ratios. But, yep, they are not a pure substance, they are mixtures. Just so you guys know, just because something is a solution does not mean, like, when I think of a solution, I naturally think of, dissolving something like salt in water or sugar in water or making Kool-Aid or something where I have like a solid that I dissolve in a liquid. Believe it or not, solutions can be any combination of solid, liquid, and gas. Okay, and so here are just some examples of that. So fog. Fog is a solution, believe it or not. It is a liquid dispersed in a gas. So you have water vapor, moisture in the air, that is spread out, and yeah, it's actually a solution. Smoke is a solution. Okay, when you see smoke, you're not seeing gases. What you're seeing is the uncombusted fuel. Okay, those particles that are spread throughout the gas. So smoke is an example of a solution. Whipped cream is a solution. You have a gas dispersed in a liquid. You have nitrous oxide that is fluffing that cream up. Okay, so that is an example of a solution. Mayonnaise, you have a liquid dispersed in a liquid. You have oil, egg yolks, vinegar, right, to make that delicious condiment. Gelatin, Jello, it's a solid dispersed in a liquid. I don't know if you guys know this, but you may not ever eat Jello again. Jello, in case you weren't aware, what it's made out of is cow bones. When you go to these processing plants, where they are, harvesting the meat from cattle, the bones and things are left over. And so what they do is they take them and they'll put them in a big vat of acid that'll dissolve a lot of the minerals and will leave the proteins behind. And those proteins are that gelatin, that gel part. And so Jello is a solution. Marshmallows, you have a gas dispersed in a solid. Okay, I don't know if you're familiar with the movie Ghostbusters or not, but there's the Stay Puft Marshmallow Man. Marshmallows are just sugar with air puffed through them. Okay, so yep, marshmallows are actually a solution. Butter, you have a liquid dispersed in a solid. You have oils and milk fat. Ruby glass, you have a solid dispersed within a solid. Gold salts in a molten silicon oxide, or that's what glass is. So all kinds of different ratios or ways that they can be combined. Solids, liquids, and gases, it doesn't matter. Okay, a couple of terms that are important, I guess we need to get out of the way. We need to know what a solute is and a solvent. Okay, so the solute is the substance that is being dissolved. Okay, usually it's going to be the thing that's present in the smaller quantity. Not always, but usually. Okay, so the solute is the thing that is being dissolved. The solvent is the dissolving medium, the thing doing the dissolving. And usually it's going to be the thing that's present in the greater quantity. Okay, and here's another hint. The resulting solution usually ends up looking more like the solvent than the solute. Okay, so those are just some kind of hints and tips as far as determining what's a solute and what's a solvent. So, like for example, if I make salt water, if I put the salt in the water, the salt is going to be there in a lesser quantity. It's going to dissolve away and look like, water. So, salt is going to be the solute. Same thing, if you look at like pop, the sugar is the solute, the thing that is being dissolved. Carbon dioxide, also in pop, is the solute. Carbon dioxide is dissolved in there, and you open the cap or pop the top on a can and the carbon dioxide starts coming out of solution. We'll talk about that, but yeah, it is being dissolved within that water. And in both of these cases, the solvent is going to be water. Water is usually going to be the solvent in most things. Not everything we do, but water is, as we've mentioned before, the universal solvent. It does a good job dissolving a lot of things. And think about salt water or pop. The resulting solution has properties more in line with that of water than it does the things being dissolved in it. A couple of other important things you need to be aware of, like dissolves like, we kind of talked about this. So if you have nonpolar solutes, they dissolve best in nonpolar solvents. So nonpolar means no charged ends, all right? They share electrons equally throughout them. So things like fats, steroids, waxes tend to dissolve in things like benzene, hexene, toluene. All these things like nonpolar solvents. If you've ever been around like any kind of chemicals you might have like in your garage, like mineral spirits or paint thinner, stuff like that, you'll notice those things have a very particular odor. Gasoline, believe it or not, is a nonpolar solvent. Gasoline, like if you have something that water doesn't dissolve real well, I can almost guarantee you gas is going to be something that will dissolve it. Okay, I cannot condone this because it's probably not safe, but like if I'm working on my mower or something, I get grease on my hands, grease and oil, and I can't get it off with the water, I might just put a little gas in my hands and rub them together, and it'll definitely dissolve it. So, nonpolar solutes dissolve best in nonpolar solvents. And then, like we mentioned before, anything that is polar or ionic will dissolve in polar solvents. So polar, meaning it has positive and negative ends in a covalent compound. Ionic, you guys know what ionic is. That's cations and anions, or positive and negative ions. So if you have a polar solvent, it'll dissolve those things. So inorganic salts, that's like when we're naming ionic things, it's like sodium chloride, potassium iodide, any of those things where you have a metal and a nonmetal. And then sugars, they actually can dissolve in polar solvents. Like if you look at like water will dissolve. Oh, hold on one second here. All right, we got that taken care of. So anyway, these polar solvents like water, we talked about water being a polar solvent. Small alcohols, you don't need to worry about that, but acids tend to also dissolve ionic substances fairly well. Like acetic acid is an example. That's vinegar. Let's see. We're not going to do this right now. We'll do molarity. This is the one we're going to use. We'll do that one later. Real quick, I did want you to know something about the effects of pressure on solubility. Pressure has little to no effect of solubility of either solids or liquids, but it does affect the solubility of gases. And so the more pressure, the more easily you can dissolve gases. You don't need to know Henry's law. We're not going to do the calculation of this, but as an example, you guys have all had, like a bottle of pop, right? And you unscrew the lid, and then you hear that hiss of air, then you see all those bubbles coming out. Well, those bubbles are carbon dioxide. They've been put in there. They're held in there with pressure, right? So if there's more pressure, it'll dissolve more gas. And when you remove that pressure by opening the cap, the gas fizzes out. And so we're going to do a thing tomorrow with temperature, how temperature affects solubility, and it affects solubility of solids and gases in a different way. Just be aware that dissolving a solid occurs faster at higher temperature, or not only faster, but you can also dissolve more of it. And the solubility of gases increases with lower temperatures. The best example I can give you of this, if you guys pay attention, sometimes in the summer we'll have these events called fish kills, where we'll get a string of like really hot days where the temperatures are in the triple digits. Well, what happens is the temperature of the water gets really high. It can't dissolve very much gas, and so all the oxygen comes out and all the fish suffocate. And so you'll go to a lake and you'll see thousands of dead fish just floating on the surface. And it's not because they were poisoned, it's because just all the oxygen came out of the water. Solubility trends. So solubility of most solids will increase with temperature. The rate at which solids dissolves will also increase if you have more surface area. So like if you crush it in a powder, it's like if you're dissolving like sugar in your coffee. If you put the granulated sugar in there, it dissolves much faster than if you put a cube of sugar. Solubility of gases decreases with increased temperature. We just talked about that. And the solubility of gases increases with pressure. And we talked about pressure and solubility. So anyway, solids will dissolve best when they're heated. When you stir them, you agitate them, or if you grind it into small particles, all right, they have a lot of surface area. Gases tend to dissolve best when the solution is very cold and when you have high pressure. Couple of other things we're going to look at, a couple other terms here. Saturation of solutions. A solution that contains the maximum amount of solute that can be dissolved under normal conditions, it's said to be saturated, so it's holding as much as it can. A solution that has less solute than a saturated solution is called unsaturated. That means it has the ability to dissolve more solute. And then a solution that contains more dissolved solute than a saturated solution is called supersaturated. Generally, what this involves is that you'll have something that is, you heat it up and you saturate it, and then you tend to cool the solution down, and the dissolved solute will stay suspended in that solution until you agitate it. And I'll show you a demonstration of that later. Tomorrow we're going to look at some solubility charts and do some calculations with those. Couple last terms I want to give you, a couple vocab things. Suspensions and colloids. It's important to note that suspensions and colloids are not solutions. A suspension is something where you have particles that are large enough that they settle out if the solvent isn't constantly stirred. Best example I can give you of this is like river water. Okay, river water, you got the river flowing, and it stirs up all the sand, silt, clay. It's got a high turbidity. It's got a lot of just junk floating in it. Okay, and so if that water stops flowing, all that stuff will settle to the bottom. Go down to the river and get a glass of water and pull it out of there, and you'll see it's real muddy. But if you leave it set over time, that all that sand, silt, and clay will settle to the bottom. Okay, so they're large enough that gravity will settle them out. A colloid is a little different. Okay, the particles are smaller than that in a suspension, and they're small enough that they don't settle out. Okay, and so a best example I can give you of a colloid is like milk. Okay, milk is basically water that has fat floating in it, little globs of fat. Okay, the fat globs don't settle out; they stay, suspended throughout the milk, and so you don't have to shake it up; it stays in there. Probably the easiest way to determine the difference between a suspension and a colloid in a solution is this thing called the Tyndall Effect. Okay, colloids scatter light, okay, making a beam visible, whereas solutions do not. And so here you can kind of see with this, they've got a laser pointer. You can't see a line here, but you can see a line through this one. Okay, so if you had a suspension, you can generally see the laser if it's clear enough. If it's opaque and the light can't shine through, then it won't. But colloids, the particles, they're small enough you can't see them with the naked eye, but if you like shine a laser through them, they'll reflect light. So that's kind of the difference. That's the thing called the Tyndall effect. And so which one's a colloid? Solution, colloid. There you go. So that's it for today. We'll do some practice tomorrow with reading solubility graphs and doing some math with them. Have a good one.